All right, so continuing our next example. So, as I have mentioned, not everything that needs problem solving has to have an equation. Sometimes you have to understand what the question or what the problem is asking of us to do. Okay, so let me give you an example of a problem that does not require equations or anything like that. Okay, so for example, here you are an engineer programming the automatic gate for a 50-cent toll. Okay, so that is the payment for the toll. The gate only accepts exact change and it does not accept pennies. Okay, so no pennies. How many coin combinations must you program the gate to accept? All right, so let's take a look what are being given to us in the problem. So in the problem, the toll must be for 50 cents, all right? There needs to be no pennies that can be used to make the payment, which means what kind of coins are we allowed to use? So if there are no pennies, the next option that you will be using would be nickels, okay, dime, quarter, okay, and then you also have your 50 cents or your $half, okay. Definitely $1 will not go because we are only allowed to pay 50 cents for the toll. So now the question is, how many coin combinations? So we need to identify the number of combinations. So we need to list on how we can mix and match these coins so that their sum would always be 50 cents. Okay? So pretty much that is going to be our plan. So we need to list the coins, so that the sum is always equal to 50 cents. All right? So we do not include pennies. So in this case, do we need an equation? Definitely no. So we can write it on a list. We can use a table to do that. All right? So let's tally. Let's include the different coins that we are allowed. So we have the $half. Let me use H for it. Okay. Followed by the quarter. That's 25. And then the dimes, which is 10. And then your nickels. These are your fives, okay? So remember, this is 50. This is 25. That's the value. This is 10. And then this is 5. All right, so let's have the first list. So the first coin combination would be, what if we have a $1/2? How many other coins do we need? Well, this is already a 50-cent value, so we don't need any more of these others, correct? Okay, we don't need them. All right, so that's one possible way. Now let's have the next possible scenario. What if we don't use? No $half included. So how many quarters do we need to get a 50? So we need 2 quarters of it. 25, 25, that's going to give us 50. Do we still need dimes and nickels for that combination? Nope, we don't need. This is already 50. Okay? Now, what if we only use 1 quarter? So if we have 1 quarter, okay, so that's a 25, okay? How many dimes do you need to get another 25? Well, you need 2 of these. So this is a 25, this is a 20 now. Then you are going to need 1 nickel as well. So that's a total of 50 cents. Now, what if we only use 1 dime instead of 2? So let's figure that out. So we don't use a $half. The quarter, again, is just 1 quarter, so 25. What if we only use 1 dime? So 25 plus 10, that's 35. So how many more 5s do we need? So that will require us to use 3 nickels to get a 15. All right? So if you are going to follow this trend, so you're going to continue listing. What if I don't use any dime? Okay? So we have 0 of this, so 1 quarter. And what if I don't want any dimes? How many nickels will I need? So if this is a 25 cent already, how many nickels can I get another 25 cents? So that would be 5 pieces. All right. So these are just some of the combination. And if you continue listing them down, this is actually what the result will be. So we were already able to list up to here. So 1/4, no dime, that will need us 5 nickels. So this time, what if we don't use the $half, no quarters? How many combinations of dimes and nickels can we come up with? So to be an exact 50 cents, you can have 5 dimes, or just use 4 dimes and 2 nickels, or 3 dimes and 4 nickels, 2 dimes and 6 nickels, 1 dime, so that's 10, and then 8 nickels. And if we decide not to use any of the half, quarter, or dime, we need a total of 10 nickels to come up with 50 cents. All right? So these are all the possible coin combinations that we can create so that we can pay a toll, an exact fee of 50 cents without the use of pennies. So if we're going to count, how many combinations are this? So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay? So we already carried out the problem, I should say, carry out the plan. So if we take a look, there's a total of 11 possible combinations. And how are you going to check? Well, you got to make sure that you used up all the coins based on our number here. Okay? You always double check. Did we add the correct number of coins? Did we get the correct values for the coin and the numbers of coins being used? Okay? So this is an example wherein you don't need an equation. Okay? Sometimes you just need a list. All right? So another scenario wherein an equation is not needed to be used is this scenario wherein you can use a diagram instead of a table or a list. Okay, so we have 4 runners. We have Maria, Aretha, Thelma, and Debbie. So 2 points are awarded to the women finishing first and second. First place, of course, gets more points than the second place winner. The question is, how many different arrangements of first and second place winners are possible? Okay, so we know that we have 4 runners: Maria, Aretha, Thelma, and Debbie. And also, according to the scenario, there is a first placer, so first place, and there's going to be a second placer. That's always the scenario. Okay. Now, how many combinations of first, second will we need? So how are we going to devise the plan for this? So you can identify an example. So let's say we choose Maria as our first placer. Okay? If she is the first placer, how many possible second placers could be in there? Well, there are 4 girls. One of them is already in first place. So you have 3 possible second placers. It could be Aretha. It could be Thelma. It could be Debbie. Correct? So pretty much, this is how it would look like. So how many combinations this will be if Maria is the first placer? If Maria is the first placer, there are 3 ways that it could end up. Aretha could be second, or Thelma could be second, or Debbie could be second. So this is already 3 possible ways of how to do that. So that is our plan. So what if we put each of the girls as the first placer, and then we can list down what are the possible combinations, all right? So again, we started with Maria. So either Aretha, Thelma, or Debbie is going to be the second placer. Now, what if Aretha is the first placer? So who will be the second? Well, it could be Maria, Thelma, or Debbie. Okay? But what if Thelma is the one that's in the first place? If it is in first place Thelma, that would be Maria could be second, Aretha could be second, and also Debbie could be second. And the last possible option is what if Debbie is the one in the first place, who would be on the second place? It could be Maria, Aretha, or Thelma in there. So these are all the possible ways on how the girls could be arranged as first placers and second placers. So how many all in all is that? So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 possible ways on how the girls could win as first placer and second placer in the race. Okay, so we can confirm, and you can always double check. Did you get all the ladies in the first place? Yes, as you can see, everybody had the chance to be a first placer. And then of course, you gotta check that the second placers are not the one in first place anymore. And so you can confirm here that there are 12 possible combinations for the result of the race. Okay, so pretty much that sums it all up. A lot of the more word problems that you will encounter, especially in math, would require equations to be set up. But you have to remember that not everything needs to be solved in that way. Sometimes it is important that you understand what is being asked in the problem. And there will be times wherein an equation is not needed. Instead, it could be a list, it could be a diagram, just like what we had here, to be able to solve the given problem. All right, thank you.